Next problem is me trying to create something where you can use polynomial functions in some applied sense. So we thought about clay being dropped out of a window and doing a little bit of bouncing before it sticks to the ground. Alright, Pierre.
Okay, you're given the function of height equals 0.5 x plus 3 squared times x minus 1 squared times x minus 2 squared. So the first question asks to make a sketch of the graph of the given domain. Since you're given your zeros, you can sketch your zeros in. And you know that you have an even multiplicity, so you know that you will bounce. B, find the initial height of the clay. So if you use using the formula, you set x to 0, and if you put x in 0 in for x in your original equation, you get 18 feet. So the clay was thrown out the window at 18 feet. The second part of the question asks, at what time is the clay on the ground? So going back to your graph, if you think about it, your x values represent your time and your y values represent your height. You cannot have a negative a negative time, so the important part of the graph is from 0 and on. So it's on the ground at 1 second and 2 seconds. And what's that other question? For what time is the clay's height increasing? So once it hits the ground at 1 second, it bounces a little bit, and it gets another maximum, which is at 1.5. Yep. And the last question: why does the model make physical sense, and why do we need the domain restriction? So once again, you cannot have a negative time, and you know that once it hits the ground at 1 second, it bounces again at 2 seconds, and at 2 seconds it was stated.
So the clay is just sticking to the ground at 2 seconds. It's no longer bouncing around.